What if you gave 3 of the most powerful AI models in the world the exact same MCP server, the exact same tools, and the exact same instructions, and watched what happened? That is not a hypothetical. I actually did it, and the results were wild. This is a real head-to-head test of Claude, GPT-5, and Gemini on a live MCP server, and only one of them used it correctly. Before we get into the results, I want to be clear about why this test matters. Most comparisons you see online test these models on writing, math, or coding. Those benchmarks are fine, but they miss something important. In 2025, what developers actually need to know is how these models behave when they are connected to real tools. That is where agent workflows live or die. So let me quickly explain what an MCP server actually is, because this term gets thrown around without much explanation. MCP stands for Model Context Protocol. It is an open standard, originally pushed by Anthropic, that gives AI models a consistent way to discover and call external tools, read from data sources, and return structured results. Think of it like a universal adapter between a language model and the rest of your software stack. Before MCP, every tool integration was basically custom work. You would write a system prompt that described your function, handle the parsing yourself, and pray the model return JSON in the right shape. MCP standardizes all of that. The server exposes a list of tools with defined schemas, and a compliant model is supposed to read those schemas and call the tools correctly without any extra handholding. Now here is the setup I used. I built a small but realistic MCP server with 5 tools, a web search tool, a file read tool, a calculator, a weather lookup, and a database query tool. Each tool had a clear schema with typed parameters and descriptions. I wrote 10 tasks that required using at least 2 of those tools in sequence. Every model got the same system prompt, the same server definition, and 0 additional coaching. I scored each model on 4 things: did it call the right tool, did it pass the correct parameters, did it handle a tool error gracefully, and did it chain multiple tools together when the task required it. 10 tasks, 4 criteria each, so a maximum score of 40 points per model. Let me walk you through what actually happened. Claude went first. Right out of the gate, it read the tool list before attempting any task. That sounds obvious, but it is not something every model does. On the first task, which asked for the current weather in a city and then saved the result to a file, Claude called the weather tool with the correct parameters, received the output, and immediately followed up with the file write tool. Clean, sequential, exactly right. Where Claude really stood out was error recovery. On task 7, I intentionally made the database query tool return an error message instead of data. Claude read the error, adjusted its approach, and tried the web search tool as a fallback, which is exactly what a well-designed agent should do. It did not just repeat the same failed call. It reasoned about the failure and adapted. Claude finished with a score of 36 out of 40. It missed points on 2 tasks where it called tools in the right order but passed a parameter as a string instead of the expected integer. Small schema adherence issues, but consistent in its logic and in its ability to chain tools across all 10 tasks. For a developer building a production agent, that level of reliability matters a lot. Next up was GPT-5. I want to be fair here because GPT-5 is genuinely impressive on a lot of tasks. But on this test, it had a specific and repeatable problem: it often answered the question without using the tools at all. On 3 out of 10 tasks, GPT-5 just generated an answer from its training data instead of calling the tool that was right there in the server definition. That is a serious problem for agentic use cases where you need live data. When GPT-5 did call tools, the calls were mostly correct. Its parameter formatting was solid, and it handled the structured outputs well. The issue was not that it could not use tools, the issue was that it did not consistently choose to use them when it should have. In an agentic workflow where the whole point is connecting the model to real-time data, that behavior breaks things fast. GPT-5 also struggled with tool chaining. On the tasks that required using two tools in sequence, it would sometimes complete step 1 and then stop, returning a partial answer as if the task was done. You had to prompt it again to continue. For a fully autonomous agent, that kind of stalling is a blocker. GPT-5 finished with a score of 26 out of 40. Then came Gemini. Gemini surprised me, and honestly not in the way I expected. Gemini was very aggressive about calling tools, sometimes too aggressive. It called tools on tasks where a direct answer would have been faster and more accurate. And on two tasks, it called the wrong tool entirely, not because of a prompt misunderstanding but because it seemed to match the tool name by keyword rather than by reading the schema description carefully. Gemini's error handling was the weakest of the three. When a tool returned an error, Gemini would often retry the exact same call with the exact same parameters. It did not adapt. It just looped. On task 7, the one with the intentional database error, Gemini called the broken tool 4 times before giving up and returning a failure message. That kind of behavior in production would cause real problems. That said, Gemini's raw output quality was high when it did get the right tool and the right data. The final responses were well formatted, readable, and often more detailed than Claude's. So if you are building a workflow where tool selection is guided and errors are handled upstream, Gemini's output quality is genuinely competitive. But in a fully autonomous setup, the schema reading and error recovery gaps are significant. Gemini finished with a score of 22 out of 40. Here is the side-by-side summary. Claude, 36 out of 40. Strong on tool chaining, strong on error recovery, minor parameter type issues. GPT-5, 26 out of 40. Good parameter formatting when it chose to call tools, but too often bypassed the tools entirely and relied on internal knowledge. Gemini, 22 out of 40. Aggressive tool use but poor schema matching and no error recovery strategy. So what does this actually mean for you as a builder? If you are designing an AI agent that needs to reliably connect to external services through MCP, Claude is the clear choice right now based on this test. Its tool use behavior is the most consistent, and its error recovery logic is the closest to what you would want in a production system. That does not make it the best model for every task, but for MCP-based agent workflows, the gap is real. The bigger lesson here is that MCP compliance is not a checkbox. Just because a model says it supports the Model Context Protocol does not mean it handles tool schemas correctly, chains tools reliably, or recovers from failures gracefully. These are things you have to test in your specific workflow, with your specific tools. One-off demos are not enough. The space is moving fast. GPT-5's tool use behavior will almost certainly improve. Gemini's schema parsing is something that could be addressed in a future update. And Claude is not perfect either, those parameter type issues were consistent enough to be a concern on strict schemas. This test is a snapshot of where things stand right now, in the middle of 2025, and the rankings could shift. If you want to run your own version of this test, the MCP server I built and all 10 task prompts are linked in the description. The setup is not complicated. You can spin it up locally and swap in any model that supports the protocol. Seeing your specific use case tested is always more valuable than watching someone else's benchmark. If this breakdown helped you understand MCP and how these models actually handle tool use, hit the like button. It genuinely helps this channel reach more builders who need this kind of honest testing. Subscribe so you do not miss the next video, where I am running the same 3 models through a full multi-agent pipeline to see which one can coordinate tasks across multiple AI workers without falling apart. That one gets complicated fast.